This is on 5.3, Solving Equations. This is the second video, so this will be some more examples, techniques, and then I'm going to talk about double angle and multiple angle problems. Okay, here is a problem that is a little different from what we were doing. You notice that the sine is squared, so sine squared is equal to 1/2. Now I want you to recall that when you had x squared equal to 36, the solution would be to take the square root of both sides, and so x would actually have two answers, plus or minus 6. If you square a positive 6, you get 36. If you square a negative 6, you also get positive 36. So there are two answers. That's the thing to remember. When you take the square root of anything, you're going to have two answers. So on this particular problem, if I take the square root of both sides, we're going to get the sine of x is equal to plus or minus the square root of 1, which is 1, over the square root of 2. Now many of you recognize that as a rationalized number, plus or minus square root of 2 over 2, right? So this particular answer is going to have an angle in all four quadrants, where sine is positive and where sine is negative. So I want the angle in all four quadrants. Well, the angle in the first quadrant for the sine of x equal to square root of 2 over 2 is going to be pi over 4. And on this particular problem, we are just going to go over the domain 0 to 2 pi. We can make it more complicated later on, but this one will give us 4 angles. So I need the pi over 4 angle in all four quadrants. So in the first quadrant it's pi over 4, in the second quadrant it's 3 pi over 4, in the third quadrant it's 5 pi over 4, and in the fourth quadrant it is 7 pi over 4. So all four of these angles will work in this problem. So if I did, for instance, the sine of pi over 4, quantity squared, equal to 1/2, I would get square root of 2 over 2 squared, which is going to be 2 over 4, which is 1/2. So you can see that pi over 4 is going to be my answer, plus, since it's plus or minus, I want angles in all four quadrants. Okay, here's another example. First thing we want to do is collect like terms. So I'm going to add the 1 to the other side, and divide by 3. So I'm going to end up with cotangent squared x equal to 1/3. Alright, now cotangent, as you recall, is 1 over tangent. So instead of writing 1 over tangent, I'm going to do the reciprocal of 1/3. So I'm going to, instead of doing the reciprocal of this side, I'm going to do the reciprocal of the right side. So find the reciprocal. Okay. Alright, so now I am to the point where I want to take the square root of both sides. So the tangent of x is equal to plus or minus the square root of 3. Now once again, that's going to end up being in all four quadrants, right? Because tangent is positive in the first and the third, and it's negative in the second and the fourth. So this is going to give me 4 angles between 0 and 2 pi, not including 2 pi. So this is going to give me 4 angles. So I know that the angle in the first quadrant, since this is square root of 3, is going to be pi over 3. And then I want to write the pi over 3 angles in all four quadrants. And so that's my answer for that. All right. So there was a little technique, a little thing to do here. Remember the plus or minus when you take the square root. Okay, on this problem I put a little caveat here. It says there's at least 2 ways to solve this problem. And what I mean by this is that I can either, notice that both the sine squared and the cosine squared are part of the identity. The identity is sine squared x plus cosine squared x equals 1. So I could solve this problem over here by substituting for the sine squared or substituting for the cosine squared, and either one is going to get you the same answer, because what you're trying to solve for is the angle x. All right, so for just because, I'm going to solve this. I'm going to say that sine squared x is equal to 1 minus cosine squared, and I'm going to replace sine squared with 1 minus cosine squared x, and then I'm going to collect the like terms. So I'm going to add this cosine squared to the other side, and that's going to give me 1 equal to 4 cosine squared x, divide by 4, and I get 1/4 is equal to cosine squared x. All right. If I take the square root of both sides, I know that cosine x would be equal to plus or minus the square root of 1, which is 1, over the square root of 4, which is 2. Once again, this is going to give me angles in all 4 quadrants. Cosine is positive in the first and the fourth, and it's negative in the second and third. So I'm going to want all angles from 0 to 2 pi, not including 2 pi. So the cosine of x in the first quadrant, that's equal to 1/2, is going to be pi over 3. And so again, in all 4 quadrants, those 4 angles would actually satisfy that equation. Now, the only difference between this is if I had put in 1 minus sine squared over here, up here, I guess I should point when I say over here. If I had put 1 minus sine squared in here, I would distribute the 3, and then that would have been a little more complicated. This seemed a little more streamlined through here. So you may have to manipulate a little bit before you actually solve for the angles. Okay, in this part we want to talk about multiple angles, double angles, triple angles. We've seen this before when we graphed. We can see here on the graph that this blue graph is the graph of sine x. It has a period of 2 pi. It shows on this graph 360 degrees, which is 2 pi in radians. And that's one period of this graph that cycles infinitely in both directions. Okay? The red graph is sine 2x. And what we notice is that it takes about half as much space, about half as much to make one period. So that in the same 0 to 360, or 0 to 2 pi, the sine 2x actually completes 2 periods in the same as it would in a normal period. All right, and we saw this before. We know that the 2 in the sine 2x helps us determine the new period. And so a normal period would be 2 pi, and we divide that by 2, and then this period will be pi. So you can see that from 0 to pi, it completes one whole cycle. All right. Now, what this means for us when we're trying to find the angle x is that this 2 actually shortens the period. And what this means is that there will be more angles between 0 and 2 pi. 0 and 2 pi. All right, so what that means then, so even if the period, like say for instance, we want to do sine theta is 1/2. Right, here's 1/2. Well, in the red, there's 1, 2, 3, 4 angles that are equal to 1/2 between 0 and 2 pi. But on the blue graph, we can see that there is 1, 2, and that's it. So for this graph, there will be 4 angles. For this graph, there will only be 2 angles that satisfy the equation. Sine x is 1/2 will be 2 angles. Sine 2x equals 1/2. There will be 4 angles in that same period. All right, so similarly, you can see that I have both cosine x and cosine 2x graphed on here. You can also see that cosine of x is going to be the red graph, right, because it has one complete period in 2 pi, The cosine 2x, the double angle equation, is going to be the blue. It's going to oscillate 2 times over 2 pi, right? It's going to be 2 times over 2 pi, and its period, because its period is just pi. So for instance, if I wanted to find y equals the cosine, if I wanted to do 1/2, or cosine x is equal to 1/2, then if I mark this 1/2, right, it's going to cross the graph here and here in 2 pi. So this will have 2 answers. But if I do the cosine of 2x equals 1/2, right, then I would have, this is the blue, so I would have this one, this one, this one, and this one. So in other words, I would have 4 answers, because its period is pi instead of 2 pi. All right, so on the next screen, we're going to go ahead and work some of these. Okay, so now here's an example. The sine of 2x equals 1/2. This is a double angle problem. You can see I've written out some steps for you beside here. The first one, we're going to solve for the angle like we did before. We're going to treat this just like it's not a double angle, but just a regular angle, so that I know which quadrant, right? Sine is positive in the first and the second quadrant. So the angle will be equal to pi over 6 in the first quadrant and 5 pi over 6 in the second quadrant. Now, these are not 180 degrees from each other, so both of these would be 2 pi n plus 2 pi n. Okay, not quite finished. I've done the first 2 steps. I found the 2 angles for which sine of an angle is equal to 1/2. I wrote both of them as an angle plus 2 pi n because I wanted all the coterminal angles. This is not the domain of 0 to 2 pi. It's all the angles. And I'm almost done because I want to divide the angles by 2. And a way to do that is just multiply through by 1/2. So I'm going to multiply through by 1/2 both sides, both problems. So I'm going to have x is equal to pi over 12 plus pi n. And then for this one here, I would have x is equal to 5 pi over 12 plus the 2's cancel, so pi n. And these would be my answers then. This would be all the angles that fit into this equation. Because remember what the 2 does, it makes it cycle faster. So there's going to be additional angles. There'll be an angle here, 12, and then also plus pi, so it'll be this one as well. So you're going to have a lot of angles. Okay, here's another example. In this example, I have the entire expression on one side and then 0 on the other. What I want is just the cosine 4x on one side, everything else over here. So what I'm going to do is subtract the square root of 3 to the other side, and that's going to leave me 2 cosine 4x equals negative square root of 3, and then I'm going to divide both sides by 2. So that's going to leave me cosine 4x is equal to the square root of 3, negative square root of 3 over 2. Okay, so I'm thinking, where is cosine negative? Well, cosine is negative in the second and the third quadrant. So what I need is an angle in the first quadrant so that I can figure out what they are in the other quadrants. So I know that my angle, and notice I just wrote 4x, but I said the angle is equal to, the square root of 3 over 2 is a pi over 6. So this would be a pi over 6 if it were in the first quadrant, but it's not, it's in the second. So that's 5 pi over 6. And the other one would be 7 pi over 6. And its normal period for cosine is 2 pi n. So positive and negative direction, those would be coterminal angles to those. So remembering what we do, the final thing is I'm going to multiply all the way through by a fourth, both sides. and that's going to give me x is equal to 5 pi over 24 plus pi over 2n, and x equals 7 pi over 24 plus pi over 2n, and these are my answers. Now, if you think about the cosine of 4x equals something, right? This right here tells me that the period is going to be modified so that every pi over 2, there's going to be an entire period. So over the whole domain of 0 to 2 pi, I'm going to have 4 cycles, right? 4 cycles instead of just 1. And so that's a quadruple angle. So here are my answers down at the bottom. These are difficult, but you'll get them. We'll practice them some more in class. This idea that you would have actual answers like this includes a whole lot of angles that I don't have to actually do between 0 and 2 pi. So I'm going to give you a problem on the next screen that I want you to attempt and write in your notes, and I'll see you in class. Okay, here's your problem. Copy it down, work it the best you can. It'll be the domain between 0 and 2 pi, but I'd like to see you draw a unit, graph, unit circle, and see if you can figure out what the angles are for x. See you in class.